In this example, we will show that 3 plus 4 plus 5 plus n plus 2 is equal to half n times n plus 1 plus 5 for all natural numbers. We'll use mathematical induction. Again, we start with the basis step. For this, we show that n equal to 1 is true. So we have just grab the n here, which is n plus 2. Show that it's equal to a half n. And if you multiply half times n, you realize that it's the same thing as n over 2. So I'm just going to write n over 2 into n plus 5. All right, so all we're going to do now is substitute 1 for n. Wherever we see n, we put 1. So it's going to be 1 plus 2 equal to 1 over 2 into 1 plus 5. So that leaves us with 3 equal to a half times 6. So 3 is equal to 3. So therefore it's true. So the basis step is true. Now we are down to the inductive step. So for the inductive step, we're going to show that if P of K is true, that implies that P of K plus 1 is also true. So first thing, we're going to write the question in terms of K. So we're going to have 3 plus 4 plus 5 plus. So when we see n, put K plus 2 equal to K over 2 into K plus 5. All right, so that is P of K. The next thing we're going to do is we're going to write the question in terms of K plus 1. All right. So for K plus 1, we're going to look at another term in the sequence, the next term in the sequence. So that's going to leave us with 3 plus 4 plus 5 plus K plus 2. And the next term in this sequence would be plus K plus 1. So we always add 1 to the K and put a plus 2 on it. Whatever is done to one side, do that to the next side. So we have K here. It's going to be K plus 1 over 2. Even inside the bracket, we have K plus 5. So we K plus 1 plus 5. All right. So now we are on our way. And the next thing that we're going to do is we're going to replace this portion here based on what we have here. So you notice when we indicate P of K, we have 3 plus 4 plus 5 plus K plus 2 equal to K over 2 into K plus 5. So we're going to use this to replace this because it's the same thing, all right? So that's going to be K over 2 into K plus 5. Then we have plus K plus 1 plus 2, that's K plus 3. And that's going to be equal to K plus 1 over 2 into K plus 6. All right. So now we are just going to multiply the fraction, use a fraction to multiply what's in the bracket. And that's going to leave us with K square. All right. K times K square plus 5K. All of that is going to be over 2. Plus K plus 3. All right. Let me just put that over 1 because I'm going to be adding them. And that's going to leave us with K plus 1 over 2 here into K plus 6. All right. So now we're just going to add these two fractions together. Since this denominator is 2, this one is 1, so I'm going to use 2 for my LCM. 2 into 2 goes 1, so I'm going to use that 1 to multiply everything up top. So it's going to leave us with k squared plus 5k. Plus 2 into 2 is 1. 1 times k squared is k squared. 1 times 5k is 5k. All right. Plus 1 into 2 is 2. So we have 2k. Use the 2 to multiply what's in the bracket. So you have 2k plus 2 times 3, 6. And we're saying that is going to be equal to k plus 1 over 2 into k plus 6. All right, so we're getting there. So now we're going to add the like terms. So we have k squared plus 7k plus 6 all over 2. Now, if you look good, you notice that on the left side there, we have a quadratic equation. All right, so we're going to use simple method to solve it. All right, so we're going to get two numbers. When we multiply them, we get the number in the middle, and when we multiply them, we get that 6k squared. All right, and when we add them, we get a number in the middle, which is a 7k. All right, so these two numbers are going to be 1k and 6k. I'm going to use those to replace the 7k. So we have k squared plus k plus 6k plus 6. All of that is going to be over 2. That's going to be equal to what's on the right side doesn't change. So I'm just going to write it back. K plus 1 into k plus 6. All right, over 2. All right, so over here now, so you notice we have k squared plus k plus 6k plus 6. All right, so we could actually bracket these. I'm going to look for a number that can go into each of the brackets. So for the k squared plus k, we could put k into that. And that would go k time, k into k, that's 1. All right, plus for the 6k plus 6, we could have 6 in there. So 6 could go in there. So 6 in the 6k goes k. All right, plus 6 in the 6, it's going to be 1. All right, and all of this is over 2. All right, and we're saying that that is equal to k plus 1 into k plus 6. All right, so if you notice, they're looking alike now. So we have k plus 1. Since k plus 1 is there twice, we write it down once. And I write out the numbers on the outside. So it's going to be k plus 6. That's over 2. And since both sides are looking the same, so that's the right side look the same. So it's k plus 1 to k plus 6. So we can conclude that it's true for all natural numbers. All right, good. That's it. Thank you for watching. See you in the next video where we'll work through another example.